Welcome to the Curious Mind. This is your quiet corner of the night, where the noise of the day fades into soft static and the universe begins to hum. Wherever you are, tucked beneath a blanket, lying under a ceiling that might as well be sky, or resting beside the gentle light of your screen, I'm glad you're here. Tonight's slow journey is a question that has lingered in human thought for as long as we've looked up. How big is our universe? It's a question that begins small, perhaps in a child's whisper, perhaps in the gaze of someone lying on the grass, counting stars, and ends somewhere beyond numbers themselves. We can't hold the universe in our hands, but we can imagine it, measure it, and wonder at it. That's what we'll do tonight. Before we begin, a small reminder. If you find peace in these quiet explorations, a like and subscribe help this little constellation of sleepy minds grow. And if you're already part of this quiet corner of the cosmos, thank you. It means more than you might think. Now let's drift into the dark, where space unfolds like an endless breath. When you step outside on a clear night and look up, you're seeing only the beginning of the story. The stars overhead form the first visible layer of our cosmic home, what we call the Milky Way galaxy, a great spiral of hundreds of billions of stars, dust, gas, and worlds, stretched out across 100,000 light years. A light year, our ruler for cosmic distance, is the distance light travels in 1 year, about 9.46 trillion kilometers. That means if you could somehow chase a beam of light, racing at 300,000 kilometers per second, it would take you 100,000 years just to cross our galaxy. And yet the Milky Way is just one among countless others. If the universe were a city, our galaxy would be a single glowing streetlight in an infinite metropolis. Let's start from here, at home. Our solar system sits about 2/3 of the way from the Milky Way's center, on one of its spiral arms, called the Orion Arm. It's a quiet neighborhood by galactic standards, far enough from the violent star-forming regions, close enough to the gentle glow of the galactic plane. Light from the center of the Milky Way takes about 26,000 years to reach us. That means when we gaze toward that dense golden haze in the night sky, we're seeing it as it was when mammoths still walked the earth. The starlight above your roof tonight is ancient history in motion. Now imagine zooming out, past the familiar constellations, past the dark lanes of interstellar dust, until the whole galaxy is before you, a glowing spiral turning slowly through blackness. If you could travel fast enough to watch from afar, you'd see it spin once every 230 million years. The last time our solar system completed a full orbit around the galactic center, dinosaurs ruled the continents. And even that grand turning of hundreds of billions of stars, is just a small chapter. Because beyond the Milky Way, space continues. The Andromeda Galaxy, our nearest large neighbor, glows faintly 2.5 million light-years away. Its light began traveling toward us when early humans first learned to use stone tools. In another 4 billion years, the two galaxies will meet, merging into a single new one, sometimes called Milkomeda. That collision won't be a crash of stars. It will be a slow interweaving of orbits, a ballet measured in millions of years. The spaces between stars are so vast that few will ever touch. Instead, their galaxies will pass through each other like ghosts, reshaping, merging, and beginning again. So already in our first small step outward, we find distances that stretch imagination to breaking. Hundreds of thousands of light years, millions. But our question remains, how big is the universe? The answer doesn't rest in one number. It unfolds in layers, each one stranger and more beautiful than the last. Beyond the Andromeda Milky Way pair lies the local group, a small cluster of more than 80 galaxies bound together by gravity. Some are large spirals like ours, others are faint smudges of stars, no bigger than cosmic dust. Together, they span about 10 million light-years across, a bubble of mutual attraction drifting through a far greater sea. And surrounding that is the Virgo supercluster, a collection of thousands of galaxies stretching across 110 million light-years. Imagine each galaxy as a grain of sand, each containing billions of suns. Then imagine that entire beach floating in blackness, surrounded by countless other beaches, each one another supercluster. Our home, as grand as it seems, is just a ripple in a cosmic ocean. And so we keep zooming out. Beyond the Virgo supercluster lies an even larger structure called Laniakea, meaning immense heaven in Hawaiian, a web of galaxies 520 million light-years across. The Milky Way is one of its tiny threads, moving slowly through its currents, like a leaf on a vast invisible river. Laniakea is not alone. It's one of countless filaments that form what astronomers call the cosmic web, a lattice of galaxies stretching across the observable universe. The spaces between these filaments are unimaginably empty, spanning hundreds of millions of light-years. They're called voids and, within them, almost nothing exists. Yet they are part of the same grand structure, the silent architecture of everything. If you could step outside it all and look at the universe from a God's eye view, it would not look like a black void dotted with stars. It would look like a vast glowing web, thin golden threads of galaxies woven together in clusters and knots, surrounding vast dark spaces. The entire universe resembles a brain, or the roots of a tree, alive with connection, filaments pulsing faintly with light. But we can't step outside. We live inside the web, looking outward from one tiny node. And from here, we can only see as far as light has had time to travel since the beginning. That distance defines what we call the observable universe, the cosmic horizon beyond which light has not yet arrived. And that's where our story continues. When we speak of the universe, what we really mean, at least what we can measure, is the observable part, a sphere centered on us, not because we're special, but because light has a finite speed. It's taken 13.8 billion years for photons from the farthest galaxies to reach Earth, but because the universe itself has been expanding the whole time, those galaxies are now about 46 billion light-years away. So the radius of the observable universe isn't 13.8 billion light-years. It's more than 3 times that, which means the diameter of the visible cosmos is about 93 billion light-years. That's the part we can see. Beyond it, we don't know. Not yet. Think about that number for a moment. 93 billion light-years. Each light-year, a distance so vast it takes light, the fastest thing known, an entire year to cross it. And we can see that far in every direction. Every patch of sky, no matter how small, holds a corridor stretching almost 100 billion years of light. The light that reaches us from the most distant galaxies has been stretched by expansion until it's no longer visible to our eyes. It has drifted into the infrared and microwave range. When we look that far, we're not seeing galaxies as they are now, but as they were when the universe was young, barely formed, a fog of gas glowing faintly with the first stars. Astronomers call this faint glow the cosmic microwave background, the afterglow of the Big Bang. It's the oldest light we can ever see, born about 380,000 years after the beginning of time itself, when the universe cooled enough for atoms to form and light to travel freely. Before that, everything was a dense hot plasma where photons couldn't escape. That means there is a literal wall to our vision, a horizon we cannot see past, because light simply hadn't begun its journey yet. And yet the universe didn't end there. It kept expanding beyond that horizon, beyond the limits of our measurement. The cosmos we can observe is only a fraction of the whole. How large the rest is, we don't know. Some scientists believe it may be infinite. Others think it might wrap around itself like the surface of a sphere, where travelling far enough in one direction could, in theory, bring you back to where you started. The shape of the universe, as far as we can tell, is flat, meaning that on the largest scales, space doesn't curve inward or outward. It stretches evenly in every direction. But even flat doesn't mean small. A flat sheet can still be endless. Here's a humbling thought. Every time we look at a galaxy near the edge of the observable universe, we see it not as it is now, but as it was billions of years ago. Many of those galaxies no longer exist in the same form today. The universe we observe is a museum of ancient light, snapshots frozen in time, still travelling through space long after their sources have changed or vanished. The farthest known galaxy, GNZ 11, shines from a time just 400 million years after the Big Bang. Its light travelled over 13 billion years to reach us. But due to the ongoing expansion of space, that same galaxy is now roughly 32 billion light-years away. We are seeing a ghost, an echo from the dawn of creation. It's strange to think that even as we sit here, calmly breathing, light that began its journey before Earth existed is just now arriving at our planet. Photons that left ancient stars before the sun was born are touching your eyes this very moment. You are literally bathing in the oldest messages the universe has to offer. And perhaps the most profound part of it all, the universe has no edge in the traditional sense. There's no wall, no barrier, no cliff at the end of space. The observable universe is not a bubble floating in a void. It's a horizon, expanding as time passes. Every second, light from previously unseen regions finally reaches us, and our visible cosmos grows a little larger. The longer we exist, the more of the universe we can see. But paradoxically, because space expands faster and faster, there will come a time when distant galaxies drift beyond reach forever. Their light will stretch until it fades completely, leaving only the local group of galaxies bound together. Billions of years from now, future astronomers will look up and see an empty sky, never knowing that once the heavens were full. For now, though, we are lucky. We live at a time when the universe is still visible, when its story still reaches us across the dark. 93 billion light-years of stars, galaxies, and time, woven into one quiet vision. And yet our question is still not answered, because even if we know the observable universe's size, the true universe, the part beyond what we can see, may be far, far larger. Some theories suggest it could be infinite. Others hint that it might be part of a vast multiverse, a foam of countless other universes, each with its own laws, dimensions, and beginnings. But for now, we remain here, on a small planet circling a modest star, drifting through one spiral arm of a quiet galaxy, suspended inside a bubble of light 93 billion light-years wide, a tiny island of awareness in an endless ocean. If you could step outside the universe and look back, not as a traveller, but as a quiet observer floating in the dark between all things, you would not see the cosmos as a smooth, even field of light. You would see something like a living tapestry. Imagine filaments of gold stretching across black velvet, vast threads glowing softly, each one made of billions of galaxies linked by invisible bridges of gravity. Between them, enormous voids, regions so empty that a traveller could go millions of light-years without finding a single star. This is what astronomers call the cosmic web, the large-scale structure of the universe. It's not a painting, it's real. When astronomers map the positions of galaxies, what emerges is not random scatter, but pattern. The universe has a texture, a geometry, an enormous network of filaments and clusters woven together over billions of years by gravity and time. Each filament is a river of matter, galaxies, dark matter, and gas, flowing toward intersections called nodes, where clusters of galaxies gather like luminous cities. The spaces between them, the cosmic voids, are the dark seas between continents. From our small world inside one of these threads, we can't see the full scale directly. But simulations, mathematical universes built inside computers, reveal how the web formed. It began as a faint ripple in the newborn cosmos, tiny variations in density left over from the Big Bang. Over time, gravity amplified those ripples, pulling matter together into streams and knots. The result is a structure so vast that even the word enormous seems fragile against it. The largest known single structure in the observable universe is called the Hercules Corona Borealis Great Wall, a colossal filament of galaxies stretching 10 billion light-years across. Light takes 10 billion years to travel its length, longer than most of the universe's history. It's hard to imagine something that big. If you compressed our entire Milky Way to the size of a single grain of dust, the Great Wall would still be a thread spanning several kilometers. And yet, it's only one piece of the web, one bright chord in a symphony far larger than we can hear. But here's the quiet miracle. Even though these scales are incomprehensible, the forces that shape them are simple. Gravity, patient, steady, unhurried, did this. The same gentle pull that keeps your feet on the floor, the same invisible embrace that keeps the moon circling Earth, also wove the universe together. Give it enough time, and gravity sculpts galaxies, clusters, and filaments out of chaos. And yet gravity isn't the only author. Something else, more mysterious, writes between the lines: dark energy. In the 1990s, astronomers studying distant supernovae discovered something astonishing. The universe isn't just expanding, it's expanding faster. The galaxies are accelerating away from each other, as if pushed by an invisible hand. This unseen force, now called dark energy, makes up nearly 70% of the universe's total energy content. We don't know what it is. It doesn't shine, it doesn't absorb, it doesn't slow down. It simply pushes space apart, stretching the fabric itself. Dark energy ensures that the cosmic web will not stay the same forever. Over the next tens of billions of years, its filaments will thin, its clusters will drift apart, and the great structures of today will fade into lonely islands of light separated by ever-deepening darkness. It's strange, isn't it? The same universe that began as a dense, unified point is now forever pulling itself apart. And yet, in that slow unraveling, there's beauty, the kind that only change can create. Every galaxy you've ever seen, every photon that has ever reached your eyes, exists along one of those filaments. The Milky Way itself is a thread in this universal web, a strand of starlight stretching through the Laniakea supercluster. If you were to travel along that filament, you'd pass countless other galaxies, elliptical ones glowing like embers, spirals shining with blue fire, and irregular ones like smudges of cosmic paint. You'd move through pockets of starbirth and deserts of emptiness, crossing gulfs so wide that time itself would feel like water. And yet, even as you journeyed across millions or billions of light years, you'd never find a place where the universe simply stops. No walls, no ceiling, just more, always more, thinning with distance, fading with age, but never ending outright. Scientists call this homogeneity, the idea that on the largest scales, the universe looks the same everywhere. No matter where you go, the average density of galaxies, the texture of the web, the background glow, all remain astonishingly uniform. It's as if the universe, in its vastness, obeys a kind of cosmic humility. No preferred place, no special center, no edge where the light falls off. Just an even, infinite fabric, woven from the same simple threads: gravity, matter, energy, and time. And yet, the story of its size still stretches farther. Because what we can map, what we can measure, is still only a fraction of what exists. Beyond the edges of our observable sphere, the web continues, possibly forever, possibly looping back, possibly branching into realms we cannot reach or comprehend. For now, all we can do is look and listen, tracing the faint filigree of galaxies, reading the universe like a quiet braille written in starlight. The pattern tells us not just where we are, but who we are. Tiny consciousnesses woven into a structure vast enough to cradle eternity. And somewhere between one thread and another, our small spiral galaxy drifts, luminous, insignificant, and perfect. To understand how the universe became so large, we have to go back, far back, to the first fraction of a second after everything began. Before galaxies, before atoms, before even light itself, there was only energy, dense, searing, featureless. And then, in an instant so brief it makes time itself seem slow, the universe inflated. Cosmic inflation, the most extraordinary expansion in history, happened less than a trillionth of a second after the Big Bang. In that blink, the universe grew from smaller than a proton to larger than an entire galaxy. Space itself expanded faster than light, carrying everything outward in an explosive smoothness. It wasn't an explosion in space, it was an explosion of space. Every point in the newborn cosmos rushed away from every other point, stretching the very fabric of reality. Quantum ripples, tiny fluctuations at the smallest possible scales, were pulled to cosmic size, seeding the structure that would later become galaxies and stars. When inflation ended, the universe was enormous and smooth, almost perfectly uniform, with only 1 part in 100,000 of variation in density. Those tiny differences, magnified by gravity, would grow into the great cosmic web we now see. If inflation had lasted just a little longer, the observable universe might be only a small fraction of the whole, a single bubble in a foam of countless others. And that may, in fact, be what happened. According to many cosmologists, inflation didn't just make our universe big. It may have created an entire multiverse, a vast landscape of universes, each with its own laws, constants, and geometries. In some, stars might never form. In others, physics might be so different that matter itself can't exist. Ours is simply one bubble among many, expanding within an infinite sea of possibility. It's a wild idea, and yet it fits the evidence. The universe we see is flat, homogeneous, and immense beyond measure, exactly the kind of cosmos inflation would create. When we look at the cosmic microwave background, we're seeing the imprint of that inflationary moment, the universe's birthmark. The faint ripples in temperature, less than 1/10,000th of a degree, are fossils of the first quantum fluctuations stretched to cosmic size. Those ripples, frozen in light, became everything: galaxies, planets, and eventually us. So when you look up at the night sky, you're seeing the aftermath of that unimaginable event, the calm surface of a universe that once expanded faster than any motion we can conceive. Every point of light you see tonight was written into existence by those first trembling instants of time. But what does that mean for size? It means the universe may not just be big, it may be boundless. If inflation continued indefinitely in distant regions, the universe could be infinite in extent, with countless observable pockets like ours, each sealed off by horizons of light. No single observer, not even in principle, could ever see the whole. That realization changes the question. How big is our universe? Maybe unanswerable, not because the data is missing, but because the universe itself refuses to be contained. And maybe that's the quiet beauty of it. Our cosmos, in its enormity, is not a cage to be measured, but a song to be heard. Each galaxy a note, each filament a melody, each photon a lingering vibration from the beginning of time. If the universe is infinite, then every point, including the one you occupy right now, is as central as any other. There is no edge, no center, no border, just the endless unfolding of existence in every direction. So as you lie here listening, imagine the universe not as something distant and abstract, but as a living ocean, vast, breathing and expanding around you. You are floating within it, made of it, carried by it. The atoms in your body are the dust of its beginnings, and the space between them echoes with the same silence that fills the cosmos. When inflation ended, time began, and everything since, the stars, the galaxies, the stories, has been a slow ripple spreading through that first awakening. The universe has never stopped growing. It's still expanding, still stretching its edges farther from every observer, like a breath that never ends. And yet somehow, in the middle of that endlessness, life appeared. You appeared, listening to this, thinking about the size of the universe, aware of your smallness. And in that awareness, something miraculous happens. You and the universe become the same thought, two sides of the same question, a whisper from infinity, wondering at itself. When the early universe cooled enough for atoms to form, light broke free and began its 13 billion year journey toward us. But the cosmos itself was still dark. There were no stars yet, no galaxies, only a vast ocean of hydrogen and helium adrift in expanding space. For nearly 100 million years, the universe was silent, a fog of invisible gas stretching in every direction. Then, slowly, gravity began to gather the mist. Tiny ripples of density, left behind by inflation, became wells, and into those wells, matter fell. The first stars ignited, scattering light into the primordial dark. These were not gentle suns like ours. They were enormous, burning blue and white, 1,000,000 times brighter, and they lived fast and died young. Their deaths, supernovae more powerful than anything since, seeded the cosmos with heavier elements. Those explosions became the midwives of galaxies. And so, the large-scale architecture of the universe took shape, immense islands of stars and dust, bound together by gravity, adrift in a limitless night. Every point of light you see in the sky, every glittering speck, is a member of one of those islands. Our own galaxy, the Milky Way, is a vast spiral about 100,000 light-years across. Its luminous arms contain hundreds of billions of stars, woven together by invisible filaments of dark matter. From afar, it would resemble a soft whirlpool of starlight, silver and gold dust circling a glowing heart. At the centre of that whirlpool lies something extraordinary, a supermassive black hole called Sagittarius, a star. It's about 4 million times the mass of our Sun, yet it occupies a region smaller than our solar system. We can't see it directly, but we can watch its influence. Stars whip around it at thousands of kilometers per second, tracing invisible orbits through bent space-time. It's strange to think that every great galaxy, every giant spiral and elliptical we've ever observed, harbours such a monster at its core. Black holes, once thought to be rare curiosities, now appear to be the silent architects of galaxies. Their gravity shapes the flow of gas and dust, their energy regulates starbirth. In a way, galaxies and black holes grow up together, parent and child, sculptor and clay. But the Milky Way is not alone. Across the night, there are billions of galaxies, each with its own central heartbeat. Some are elegant spirals like ours. Others are swollen ellipses, smooth and featureless, remnants of ancient collisions. Some are ragged irregulars, galactic sketches still unfinished. If you could fly between them, the scale would be almost unbearable. The average distance between large galaxies is millions of light-years. That means the light from one galaxy can travel for eons before ever brushing another. Yet on the largest scales, they are not scattered randomly. They cluster, forming filaments and sheets, tracing the same cosmic web we spoke of earlier. The Hubble Ultra Deep Field, a tiny image captured by the Hubble Space Telescope, revealed what happens when we stare into apparent emptiness. In a patch of sky no bigger than a grain of sand, held at arm's length, Hubble found over 10,000 galaxies, each one a world of hundreds of billions of stars. Multiply that across the entire sky, and the numbers defy comprehension. If you could somehow count them all, you'd find that the observable universe holds at least 2 trillion galaxies, and within those galaxies are an estimated 200 billion trillion stars. That's a 2 followed by 23 zeros, a number that hums like infinity itself. And yet this sea of light is mostly darkness. For every atom of visible matter, there are 5 atoms worth of something unseen. Dark matter, a mysterious substance that neither emits nor absorbs light, but reveals itself through gravity. Without dark matter, galaxies could not exist. Their stars would fly apart. It's the invisible skeleton of the cosmos, holding everything together. The Milky Way, too, swims in a halo of this dark material, extending far beyond its visible edge. We live not in the centre of light, but in the gentle curve between 2 spiral arms, orbiting quietly amid an unseen sea. When you look up tonight, remember, that faint river of stars arcing across the sky, the Milky Way, is both home and horizon. What seems like a band of cloud is really the inside view of our galaxy's disk, billions of suns blurred by distance. You are seeing our neighborhood from within, peering through a window made of light. And beyond that window, more windows stretching forever. Each galaxy spins, drifts, collides and evolves. Galaxies merge like raindrops coalescing on glass. Small ones are devoured by large ones. New stars are born from the ashes of the old. Over cosmic time, spirals can flatten, ellipticals can swell, and the glow of starbirth can fade into quiet embers. The universe is not static, it's a living architecture, always building, always eroding. Some galaxies are giants, spanning 500,000 light-years. Others, called dwarfs, are tiny, collections of a few million stars loosely bound, like fireflies huddled in the dark. Our Milky Way has dozens of such dwarfs orbiting it, silent companions that trace its gravitational field. The vast majority of space between galaxies is empty beyond imagining. If you placed a single atom inside a cubic meter of intergalactic space, that volume would be unusually dense. Yet even emptiness has structure. Filaments of gas stretch between clusters, connecting galaxies like luminous veins. Light from distant quasars passes through them, revealing their faint fingerprints in spectral lines, a cosmic cartography written in starlight. Every one of those galaxies and every photon they emit is part of the story of size. When we ask, how big is our universe? The answer hides not just in distance, but in number. The vastness isn't just width, it's multiplicity. A billion upon billion of places, each one with its own suns, its own chemistry, its own chance at life. And that thought somehow makes the darkness feel less empty. Because the more we learn about the architecture of the cosmos, the more it resembles something living, a great network of light and silence, breathing across time. Our galaxy is one note in that symphony, a brief glowing chord in an endless composition called the universe. When we speak of the universe's size, we can't separate it from time. Out there, distance and duration are the same thread, woven together by light. To see far is to look back. Every photon carries a timestamp from the past. The universe, according to our best measurements, is 13.8 billion years old. That number feels solid, but it's a kind of poetry, a way of saying the cosmos has been unfolding for longer than imagination can hold. Think of a single second, now think of a million, now a billion, now multiply that by 13. Each second a heartbeat of the universe, each heartbeat birthing stars, galaxies, and the slow rhythm of expansion. We humans experience time as a river, but the cosmic river flows in strange ways. Near massive objects, time slows. In the deep voids between galaxies, it rushes faster. The clock on your wrist and the clock on a distant world will never quite agree. Across billions of light years, even time itself bends and stretches like light through glass. To measure the universe, astronomers use what's called the cosmic distance ladder. It begins close to home, with radar and parallax, measuring the wobble of nearby stars as Earth moves around the Sun. Farther out, they use standard candles, objects like Cepheid variables or Type Ia supernovae, whose true brightness is known. By comparing how bright they appear, scientists can calculate how far away they are. At the top of the ladder sits the Hubble constant, the rate at which the universe expands. It tells us how fast galaxies recede with distance. But here lies a mystery that still keeps cosmologists awake. Two different methods give two different answers. The local measurements, based on nearby galaxies, disagree with the cosmic background estimate based on the early universe. The discrepancy, called the Hubble tension, may be a clue to new physics waiting just beyond our reach. Yet even with uncertainty, the scale remains staggering. Light that left some galaxies when the Earth was forming is only arriving now. the most distant light we see began its journey before the Milky Way had arms, before our sun existed, before there was an us to wonder. If the observable universe is 93 billion light-years across, then every direction you look is a view through 13.8 billion years of history. The stars you see tonight are not there anymore, not exactly. Some have died, others have drifted, many have changed beyond recognition. The night sky is a mosaic of ghosts. Even the colours of starlight tell stories of time. Light stretches as it travels, pulled by the expansion of space. Its wavelength lengthens, shifting toward red. The farther the galaxy, the redder its light appears. This cosmological redshift is our map of the universe's growth. Each increment of red is a measure of time itself. Through this, astronomers have drawn a timeline of everything that ever was. The first atoms, forming 13.8 billion years ago. The first stars, igniting 13.3 billion years ago. The first galaxies, gathering 12.8 billion years ago. The Milky Way's birth around 13 billion years ago. The Sun's formation, 4.6 billion years ago. The Earth's first oceans, 4 billion years ago. The rise of life, the pulse of consciousness, the sudden awareness looking back. From the Big Bang to now, the universe has expanded by a factor of over 1 trillion. What was once smaller than a proton is now larger than all thought. And here we are, measuring it. Tiny creatures of carbon and curiosity, pressing numbers into infinity's margin. It's tempting to think of ourselves as spectators, but we are participants. Every breath you take contains atoms forged in supernovae. Every heartbeat is powered by fusion, born in the same laws that shape galaxies. Time is not something outside us, it moves through us. So when we ask, how big is the universe? We're also asking, how long has it been dreaming itself into being? The two questions are one and the same. Somewhere out there, light is still travelling from the first stars. Somewhere farther still, regions of space expand so fast that their light will never reach us. Beyond that lies the unknown, the part of the universe that will remain forever beyond sight. But perhaps that's all right. Perhaps mystery is part of the design. The universe doesn't owe us closure, it offers wonder instead, and that is enough. Tonight, as you close your eyes, imagine yourself drifting backward through time, past the birth of our sun, past the swirling nebula of the Milky Way, past the first galaxies, until you reach that luminous fog where the universe itself was still learning to shine. You are made of that same light. You are the cosmos, looking inward, remembering itself. The universe is not a static painting. It is a motion, a slow, eternal inhale. Everything we see, every galaxy and cluster, is part of that single breath. When astronomers look deep enough, they see not just the past but the pulse of expansion itself. Galaxies moving away, space stretching, time elongating, like light in glass. In 1929, Edwin Hubble made a discovery that changed how we understand everything. He measured the light of distant galaxies and found it was redshifted, stretched toward longer wavelengths. The farther the galaxy, the greater the redshift. This meant one simple, staggering thing. The universe is expanding. At first, the idea seemed impossible. For centuries, humans imagined the cosmos as eternal and unchanging, a grand, infinite clockwork. But Hubble's observations showed that the clock wasn't fixed at all. It was growing. The galaxies were not flying through space like bullets after an explosion. Rather, space itself was expanding, carrying the galaxies with it. To visualize it, imagine raisins in a loaf of bread. As the dough rises, each raisin moves away from all the others, not because it's traveling through the dough, but because the dough itself is stretching. That's our universe. Space isn't the stage, it's the actor. Since that discovery, scientists have measured the universe's expansion with increasing precision. They've found that the rate isn't constant, it changes over time. In the early universe, gravity tried to slow the expansion, but billions of years later, a mysterious force began to accelerate it. We call it dark energy, and it now drives the cosmos outward faster than ever before. This expansion means there is no true center of the universe. Every point in space sees every other point moving away. If you stood on a distant galaxy and looked back toward the Milky Way, you'd see us receding just the same. From every vantage, the universe expands equally. The center is everywhere, and nowhere at once. And the scale of that expansion is breathtaking. Every second, the observable universe grows larger by 300 million meters, nearly the distance from the Earth to the Moon. Space is continuously generating more space. What began as a tiny flash of creation now swells into a cosmic ocean without end. But how far can it go? How large can the universe become before expansion outpaces light itself? To answer that, we must understand cosmic horizons. There are two. The particle horizon marks the distance light has travelled since the Big Bang, about 46 billion light-years in every direction. That's the boundary of what we can see. But there's another stranger boundary, the event horizon. Beyond this, galaxies recede faster than light due to expansion. Their photons will never reach us, no matter how long we wait. Those regions are not gone. They are simply unreachable, forever beyond communication. In a sense, the universe is stretching faster than it can talk to itself. Every year, more galaxies drift past that horizon. Their light fades, their voices fall silent, and the visible universe becomes a little lonelier. Billions of years from now, observers in our galaxy will see nothing but a dark void. The cosmic web will have dissolved into isolated islands of light surrounded by infinite night. That might sound sad, but it isn't. It's the natural rhythm of things. Every expansion is also a return to quiet. The universe, like a breath, rises and falls in patterns too vast for us to fully sense. Right now, we exist at a rare moment in cosmic history, a window of visibility. We can still see the echoes of the Big Bang, the birth of galaxies, the distant edge of time. The universe is old enough for intelligence to arise, but young enough for the sky to remain filled with light. We live in a luminous moment between darknesses, the universe awake, aware of itself, whispering through minds like ours. It's humbling to realize that as space expands, time expands too. Each second of cosmic history becomes a larger interval in the grand fabric of existence. What was once a single vibration of energy now stretches into centuries. The universe isn't merely growing in size, it's stretching in every dimension, including the unseen ones that shape reality. If we could see it from outside, if such a perspective were possible, we'd watch it unfold like a vast, glowing sphere of light, rippling outward across nothingness. Every flicker of starlight, every human thought, every atom's vibration, carried outward in that infinite bloom. Expansion is not chaos. It's the universe's way of continuing. It tells us that creation never really stopped. It just slowed, cooled, and changed form. The galaxies are the embers of that first fire, still drifting, still glowing, still widening the edges of existence. And as we drift with them, the question deepens. If the universe is expanding, what is it expanding into? The answer is quiet and strange. Nothing. Space doesn't expand into anything. The expansion is the growth of something, where there was no somewhere before. New space is continuously forming between galaxies. The universe isn't moving through the void, it is the void, unfolding. And that may be the most beautiful idea of all, that we are not surrounded by space. We are part of its expansion, a ripple in its ongoing creation. So when you look up at the stars tonight, know that you are watching a universe still being born. The galaxies are not distant history. They are still moving, still opening their arms, still making room for everything that will ever exist. The universe breathes, and you breathe with it. All things end. Stars burn out, galaxies merge, even atoms decay. But when we speak of the universe, ending takes on meanings far beyond imagination. Because what could it mean for everything to end? For time, space, and light themselves to cease. The truth is, the universe's fate depends on a delicate balance between gravity and dark energy. Gravity pulls inward, trying to slow the expansion. Dark energy pushes outward, accelerating it. Which one wins will decide the universe's destiny. For most of the 20th century, cosmologists imagined three possible endings. The Big Crunch. If gravity was strong enough, the universe would eventually stop expanding and collapse back in on itself. Galaxies would reverse course, stars would fall together, and all of space would heat into a final, blinding implosion, perhaps followed by a new Big Bang. The Big Freeze. If expansion continued forever, galaxies would drift apart, stars would burn out, and the universe would fade into eternal cold. The Big Rip. If dark energy grew stronger over time, it could eventually tear apart galaxies, stars, planets, and even atoms, ripping the fabric of space-time itself. For now, evidence favours the Big Freeze. The expansion is accelerating, but not violently. It's gentle, steady, relentless. In this scenario, the universe's future is long and quiet. Trillions of years from now, new stars will stop forming. The bright spiral galaxies will fade to red, then to black. White dwarfs will cool into dark remnants, called black dwarfs. Neutron stars will drift through endless night. Eventually, even black holes will evaporate. Stephen Hawking showed that they slowly leak radiation, a process so slow it takes 10 to the 64th power years for a stellar black hole to vanish. When the last one fades, the universe will enter its final age, a thin soup of particles and low-energy photons spread across infinite space. It's not a fiery end, but a gentle one, a return to quiet. And yet even that may not be the final word. Some theories suggest that, as the universe grows older, quantum fluctuations could create new bubbles of space-time, tiny universes budding off from the old, each with its own Big Bang. In that sense, the universe never truly dies. It simply transforms, passing its light forward like a torch. Others imagine a cyclic cosmos, one that expands, collapses, and expands again in endless rhythm. In such a model, our Big Bang was not the first, nor will it be the last. The universe might be eternal after all, pulsing between creation and silence like a heartbeat too vast to measure. But here's a quieter thought, one that doesn't need equations or endings. Maybe the universe doesn't need to end for it to complete its purpose. Maybe its purpose is its expansion, its constant act of becoming. Right now, in this moment, the cosmos is still allied with motion. Stars forming, galaxies colliding, light travelling, consciousness wandering. Every instant is both the end of something and the beginning of something else. The atoms in your body, once locked inside long-dead stars, are part of this great cycle. When the last star flickers out, its remnants will drift into space, perhaps to form something new, a cloud, a spark, a new universe. The story doesn't stop, it changes its rhythm. Even if the cosmos fades, its memory will persist, not in matter or light, but in the simple fact that it was. Existence itself is the echo that never ends. And so when we ask how big is our universe, perhaps the truest answer isn't measured in light years or ages. Perhaps it's measured in the depth of its continuation, the endless capacity to make and unmake, to burn and cool, to dream and dissolve. The universe may not be infinite in space, but it is infinite in becoming. And as you listen to this, somewhere in a galaxy, millions of light years away, a star is being born. Its light destined to travel for eons before it ever touches another consciousness. Maybe that light will one day fall on another world, another listener, asking the same question. How big is our universe? And the answer will still be the same, as big as the distance between one thought and the next. When we look into the night sky, we think we are seeing the universe, a dome of stars and galaxies glowing faintly across the dark. But what we see is only a sliver, a fragment, a glimmer of a far greater whole. The universe, as it truly is not made mostly of light. In fact, all the stars, planets, gas, dust, everything that shines makes up less than 5% of the total cosmos. The rest is hidden, silent, and invisible. There are two great shadows that define the shape of everything: dark matter and dark energy. Dark matter was the first to reveal itself, not through light, but through motion. In the 1930s, astronomer Fritz Zwicky studied galaxies in distant clusters and found they were moving far too fast. According to the visible matter alone, their gravity should have torn them apart. Yet the clusters held together. Something unseen was adding weight, something massive, but invisible. Decades later, astronomer Vera Rubin confirmed it. She measured how fast stars orbited within spiral galaxies and found the same strange result. The stars at the edges moved just as quickly as those near the center. That should be impossible, unless an unseen halo of matter was surrounding each galaxy, extending far beyond what we can see. Thus was born the modern mystery of dark matter, an invisible scaffold of gravity holding the cosmos together. Today, we know that dark matter makes up about 27% of the universe. It doesn't emit or absorb light. It doesn't collide or clump like normal matter. It passes through everything, even through you, as though you were mostly empty space. And yet, without it, galaxies would never have formed. The Milky Way, Andromeda, and every glowing thread of the cosmic web owe their shape to its unseen hands. But what is it? That question, even now, remains unanswered. Scientists have proposed many ideas. Perhaps it's made of exotic particles called WIMPs, weakly interacting massive particles that rarely touch normal matter. Or maybe it's axions, ghostly particles, so light they drift like waves of possibility. Some think it could be the gravitational pull of entire hidden worlds, small black holes or even undiscovered forms of matter that exist outside known physics. So far, every experiment has returned silence. The detectors, buried deep underground, shielded from cosmic rays, sit waiting for the faintest signal. A single flicker, a single collision, could rewrite everything we know about the universe. Until that moment, dark matter remains a whisper, felt, not seen. And yet stranger still is its sibling, dark energy. If dark matter pulls the universe together, dark energy pushes it apart. It is the unseen pressure behind cosmic expansion, the mysterious force that accelerates the universe's growth. Together, dark matter and dark energy make up 95% of everything. The entire visible cosmos, all the light we've ever known, is just the foam on a vast, invisible ocean. That idea can feel disquieting. How can we live in a universe made mostly of things we can never see? But maybe that's not so strange after all. We too are mostly invisible. 99% of an atom is empty space. Even our bodies are mostly made of the unseen. Electrical fields, quantum probabilities, vibrations of energy too small to picture. Maybe the universe isn't hiding. Maybe we simply haven't learned to see it yet. And so, astronomers search. They map the cosmic microwave background, tracing its faint ripples for signs of the invisible. They watch how galaxies bend light around them, a phenomenon called gravitational lensing, where dark matter distorts the path of light like glass. They study the distribution of galaxies to understand how the unseen mass has shaped their arrangement. Each discovery is another fingerprint of something vast and patient. If you could see dark matter, the night sky would look entirely different. Instead of scattered points of starlight, you would see glowing filaments, great highways of gravity stretching across space, connecting galaxies like beads on threads. You would see halos around every cluster, faint spheres of invisible substance cradling their stars. You would see the true skeleton of the cosmos, the structure beneath the light, and you would understand that light, as beautiful as it is not the foundation of existence. It is the decoration, the shimmer on the surface of something much deeper. Our universe, as it turns out, is not made of stars. It is made of the gravity that holds them. And that realization, that what we can't see is greater than what we can, may be the most humbling truth of all. Because it means that even now, with all our telescopes, all our instruments, all our knowledge, we are still looking through a keyhole in an infinite door. The great majority of the universe waits, unseen, patient as time itself. And maybe, in some distant age when humanity has evolved into something beyond what we are now, when our senses extend beyond light and matter, we'll finally see the full portrait, a universe not dark and cold, but radiant in ways our present eyes cannot yet understand. Until then, we live among shadows that hold the stars. If dark matter and dark energy are the silent foundation of the universe, then neutrinos and gravitational waves are its quiet messengers, particles and ripples that whisper stories no light can tell. Let's begin with the neutrino. It is one of the strangest things in existence, a particle so small and elusive that billions of them are passing through your body right now, through your skin, through the earth itself, and you don't feel a thing. Every second, more than 60 billion neutrinos from the sun pass through every square centimetre of your body. They are everywhere, travelling almost at the speed of light, born in the hearts of stars and supernovae. Yet they almost never interact. A single neutrino could travel through a wall of lead a light year thick without being stopped. For decades they were called ghost particles, and yet these ghosts carry information about the most extreme events in the cosmos. They emerge from nuclear reactions, from exploding stars, from the fusion fires that keep suns alive. In 1987, astronomers detected a burst of neutrinos from a supernova in a nearby galaxy, the first direct evidence that these particles connect us to stellar death. Since then, neutrino detectors, vast underground caverns filled with pure water or ice, have been listening for their faint arrivals, flashes of blue light that mark a passing ghost. These signals tell us about processes that light cannot escape. While photons are trapped, delayed, or absorbed, neutrinos pass straight through, carrying news from the heart of the universe. And then there are gravitational waves, ripples in the very fabric of space-time itself. Predicted by Einstein in 1916, they went unseen for a century, until 2015, when the LIGO Observatory recorded a faint tremor in its laser beams, the echo of two black holes colliding a billion light-years away. That was the first time humanity had heard the universe. A new sense was born. Since then, gravitational waves have revealed neutron star mergers, cosmic collisions, and even hinted at the distant rumble of supermassive black holes, holes orbiting each other in galactic hearts. Unlike light, which can be blocked or absorbed, gravitational waves pass through everything, through stars, through galaxies, through us. They are the universe's way of speaking without words, the deep bass of existence. Together, neutrinos and gravitational waves have given us a new kind of astronomy, one that sees the invisible. We no longer observe the universe only with light, but with the movements and vibrations of space itself. This multi-messenger astronomy has transformed our understanding of size. The universe is not a silent void. It is a dynamic, rippling ocean. Every explosion, every collision, every birth and death of a star sends waves through its fabric, echoes that travel forever. Imagine it for a moment. A black hole collides with another in some distant galaxy. The energy released is greater than that of all the stars in the universe combined, for a heartbeat of time. The shock waves travel outward, warping space-time, reaching Earth after billions of years, so faint that only the most sensitive instruments can feel them. You are sitting at home, unaware that space itself just passed through you, stretched and compressed by a cosmic event older than civilization. That is the scale we live within. The universe is not still, it vibrates. Even the atoms in your body are part of this great harmony. You are woven into the same fabric that carries these ripples. When you breathe, when you think, when you dream, you are part of the same resonance that began with the Big Bang. And maybe that is the answer to how big our universe truly is. not just in kilometers or light years, but in connection. It is as large as the distance between one vibration and another, as vast as the network of invisible messengers tying every event to every other across time. You too are part of that music, a quiet note in an orchestra so large that even silence is full of song. When you gaze into the night sky and imagine its edge, that farthest boundary where light fades into silence, it's natural to ask, what lies beyond? The question hums in the quiet between stars, a soft ache of curiosity that's followed humans since the first fires. If the observable universe stretches 93 billion light years across, what is there outside that vast horizon? Does it end, or does it continue, forever, unseen, untouched, unreachable? Our instruments, bound by light and time, cannot tell us, but mathematics, that other language of wonder, offers a whisper of possibility, that what we call the universe might be only one bubble in a far greater sea. This idea, known as the multiverse, isn't fantasy. It is a natural echo of the same physics that created everything we see. Remember cosmic inflation, that fraction of a second when space expanded faster than light, stretching quantum ripples into cosmic landscapes. Many cosmologists believe inflation never stopped. It may still be happening, endlessly, in distant regions beyond our horizon. In that endless expansion, pockets of space stop inflating and form universes, bubbles like ours, while the surrounding space continues to grow. Each bubble becomes its own cosmos, with its own galaxies, its own laws of physics, its own version of reality. This process is called eternal inflation. It means there may be an infinite number of universes, a multiverse without border or end. Some might be small, others vast. Some might contain stars and planets. Others might be empty or governed by entirely different rules. In one, gravity might be stronger. In another, atoms might not even form. Somewhere perhaps there are worlds almost like ours, with skies of similar stars and oceans under familiar moons, separated not by distance, but by reality itself. It's a dizzying thought that everything we know, every life and memory and breath, could exist inside a single bubble among countless others. If this is true, our observable universe, immense as it seems, would be like a single raindrop in an endless storm, each drop reflecting its own sky, unaware of the others falling all around it. But there are other ways the multiverse might exist. Some physicists working in the strange mathematics of string theory have discovered that the universe may require more than 3 dimensions of space. There could be 10 or 11 dimensions, most of them curled up so small that we can't perceive them. In this view, our universe is a brain, a 3-dimensional membrane floating in a higher dimensional space called the bulk. Other brains could exist beside ours, each a separate universe, perhaps only a fraction of a millimeter away, yet forever inaccessible, because light and gravity are confined to each brain. Occasionally, perhaps, 2 universes might brush against each other, their contact sparking a new Big Bang. It's a breathtaking picture. Reality not as a single sphere, but as a vast ocean of membranes drifting in higher dimensions, each carrying its own cosmos. And if that sounds impossible, remember, every revolutionary idea once did. There was a time when we thought our world was the center of creation. Then we discovered the solar system, then the galaxy, then the universe. Every time we drew a border around existence, the cosmos quietly erased it. So perhaps the multiverse is not a dream, but the next natural step in our unending expansion of perspective. Yet if infinite universes exist, what does that mean for you? In an infinite cosmos, every possible configuration of matter must exist somewhere. Every possible version of you, the one who stayed, the one who left, the one who never existed, all might inhabit their own realities. Each decision, each branch of probability, unfolding eternally. It's not a story of copies, but of possibility. Each life, unique, each universe, complete. And maybe, in some distant brain of existence, another version of you is asking this same question. Listening to these same words, under a slightly different sky, the multiverse doesn't make our world smaller, it makes it miraculous. Because even in an infinity of possibilities, this moment, you, here, now, still exists. And that, somehow, is everything. If the multiverse is real, the size of the universe is beyond all measure. It is not billions or trillions of light years wide. It is endless, blooming with new creations every moment, infinite in space and in time. And perhaps, in the quiet between these words, it is still expanding. New universes forming, new laws of physics awakening, new lights being born in realities we will never see. Infinity, it seems, is not a number. It is a process. And the universe, or rather the multiverse, is still in the act of becoming. When we think of the universe, we imagine three familiar directions: up and down, left and right, forward and back. These are the axes of our daily lives, the lattice upon which all movement unfolds. But physics whispers that there may be more, hidden dimensions curled beyond perception, smaller than atoms, yet vast in implication. The story begins with string theory, one of the most ambitious attempts ever made to describe everything. It suggests that the fundamental building blocks of reality are not particles, but tiny vibrating strings of energy. The way each string vibrates determines what it becomes: an electron, a photon, a quark. Matter is music, and the universe is its instrument. But for the mathematics of string theory to work, space cannot have just 3 dimensions. It needs at least 10, sometimes 11, to remain consistent. The extra dimensions are compactified, curled up so tightly that we can't detect them. Imagine each point in space containing tiny, invisible loops folded upon themselves, microscopic universes nested within every atom. These hidden dimensions may explain the strange hierarchies of nature, why gravity is so weak, why particles have mass, why the forces of nature differ in strength. Gravity, in particular, may leak into these unseen directions, diffusing its power across higher dimensional space. If that's true, then what we experience as the vastness of the universe might only be a thin slice of something incomparably larger, a sheet of 3-dimensional space floating in a higher dimensional arena. In that higher reality, countless other sheets, other universes, could float beside ours, perhaps even touching it occasionally, like ripples in a cosmic pond. When they collide, the energy released could ignite a new Big Bang, birthing yet another universe. This is called the brain world hypothesis, and in its quiet strangeness lies a haunting thought. Perhaps our universe was born not in isolation, but from the gentle touch of 2 unseen worlds. Some scientists even speculate that dark matter might be matter from a nearby brain, interacting with ours only through gravity. If true, then the invisible mass holding our galaxies together may literally come from another universe, brushing faintly against ours, like ghost fingers, through glass. When you pause to imagine that, the word big begins to lose meaning. How big is the universe, if it might share its boundaries with others, if every atom could hold entire hidden landscapes within it? The scale becomes recursive, universes within universes, spaces within spaces, a fractal infinity that defies comprehension. It's enough to make you feel small, but also strangely infinite. Because if dimensions beyond ours exist, then perhaps consciousness itself is not confined to 3-dimensional thought. Maybe the human mind, that flicker of awareness capable of imagining infinity, is already reaching across unseen dimensions just by wondering about them. After all, when you dream, you create spaces that didn't exist before. When you imagine, you build worlds. The same physics that allows dimensions to fold and vibrate may echo in the folds of your own perception. The universe, it seems, is both external and internal, outer cosmos and inner reflection, each mirroring the other. The stars above and the thoughts within are made of the same subtle vibrations, the same quantum fabric. So when you close your eyes and picture the universe, you are not merely observing it, you are participating in it. A small consciousness inside one dimension. Reaching toward others, it can only sense in symbols and dreams. The hidden dimensions, if they exist, are not distant. They are here, wrapped around you, inside you, woven through every atom of air and skin. The universe is not out there, it is everywhere. And perhaps in the deepest layers of existence, there is no separation between inside and outside, large and small, matter and thought. Perhaps the entire universe, every dimension, every brain, every spark of light, is one continuous field, vibrating in different modes, singing a single infinite song. And that song is still being played. If the universe has a size, it must have a shape. That seems obvious. Every object we know, from grains of sand to galaxies, has boundaries, edges, curves. But the universe may be the one thing that doesn't. Imagine standing on a ship at sea. Everywhere you look, the water stretches endlessly, yet you know the earth beneath you is round. You never find an edge, you just keep circling the same horizon. The universe may be like that, finite yet unbounded. It's one of the strangest ideas in physics, and one of the most beautiful. For centuries, people imagined the universe as a vast sphere surrounded by darkness, a celestial shell dotted with stars. But as our understanding grew, the boundaries dissolved. Einstein's general theory of relativity changed everything. It told us that space itself can bend, twist, and curve, not around something, but around itself. Mass and energy tell space how to curve. Curved space tells matter how to move. It's a dance so perfect, so seamless, that the geometry of the universe is not fixed. It's dynamic, shifting with its contents. So what is the shape of the universe? Cosmologists describe three possibilities. Closed, like a sphere, where if you travel far enough in one direction, you could return to your starting point, just as a traveller on Earth might circle the globe. Open like a saddle, expanding forever, curving outward infinitely. Flat, like an infinite sheet, extending endlessly in all directions. To find out which one ours is, scientists have measured the cosmic microwave background, the oldest light in existence. They looked at how its faint ripples stretch across the sky. If space were curved inward, those ripples would appear smaller. If curved outward, they'd look larger. What they found is astonishing. The universe appears to be flat, with less than 0.4% curvature. But flat doesn't mean simple. Even a flat space can loop back on itself, like a video game world, where walking off one edge makes you appear on the opposite side. If the cosmos wraps around, we might be living in a finite universe that gives the illusion of infinity. No walls, no borders, no end, just endless continuity. When you look at the night sky, you might be seeing light that has travelled not from another galaxy, but from our own, looping through the curvature of space. A cosmic mirage stretched across unimaginable distance. It's a possibility we can't yet prove, but it lingers, a whisper that space itself may be folded like silk. And perhaps that's what makes the universe so quietly miraculous. It has no outside. There is no beyond the edge, no external void it's floating in. Space isn't inside something larger. It is all there is. When we say the universe is expanding, we don't mean it's growing into anything. We mean that distance itself is stretching between all things. There's no outside to move into, just the constant creation of more inside. It's an idea that bends the mind and soothes the soul at once. Because if the universe has no edge, then neither do we. The atoms in your body, made from the same matter and energy as stars, are part of that same seamless continuum. There's no real separation between the universe and what you call yourself. You are not in the universe, you are of it. And just as the cosmos has no boundary, perhaps neither does awareness. Perhaps consciousness itself, like space, curves back upon itself, finite in experience, infinite in wonder. Astronomers use the word geometry to describe these cosmic shapes. But it's more than geometry, it's poetry written in space-time. The universe curves, not like a ball, but like a story, folding and looping, connecting beginnings to endings in ways we can't yet see. It's possible that if we could travel far enough, we would find ourselves arriving home again, from the opposite direction, in a universe that never ended, only circled. So when you look out into the night and wonder where it all stops, remember, it might not stop at all. The universe may be round or infinite or folded in dimensions beyond sight, but it will never have an edge, and that somehow makes it even more intimate, because wherever you are in it, you are always at the center of its unfolding. We often speak of the edge of the universe, but what we really mean is the edge of time, the farthest distance light has been able to travel since the beginning. There is no edge in space, but there is a horizon in light. The observable universe, that vast sphere of everything we can see, is about 93 billion light-years across. Beyond that, the cosmos continues, but its light hasn't reached us yet. In the same way you can't see beyond the curvature of Earth, you can't see beyond the curvature of time. This boundary isn't made of matter or energy, it's made of history. When you look far enough away, you're looking back, not just across distance, but through epochs. The light from a nearby star left only a few years ago. The light from a distant galaxy left billions of years ago. Look far enough, and you reach the faint afterglow of the Big Bang, the earliest light that can ever reach us. Beyond that, there was no light at all. The universe was once opaque, filled with hot plasma, where photons couldn't travel freely. That's the wall of time we face, the cosmic horizon. Not a barrier in space, but in memory. And yet that horizon isn't static, it grows with time. Every second, light from farther regions finally arrives. The universe we can see is expanding, not because new space is forming, but because light has had more time to reach us. With every moment, the visible cosmos becomes slightly larger, like a photograph still developing. But there's a bittersweet symmetry here. Even as the observable universe grows, much of it is slipping away. Because of accelerated expansion, distant galaxies are moving faster and faster. Eventually, their light will never reach us again. The cosmic horizon will fade, and the night sky will grow dark. The story will continue, but we won't be able to read it anymore. Our cosmic window is temporary. We live at a moment when the universe is just transparent enough, just young enough, for its grand pattern to be visible. In the deep future, even that view will close. Imagine some distant civilization, trillions of years from now, orbiting the last fading stars. They'll look at the sky and see only their local cluster. No trace of the Big Bang, no glow of distant galaxies, no clue that the universe ever expanded. For them, the cosmos will seem small, static, eternal. But we live in the golden age of seeing. Our telescopes can look back almost to the beginning. We can trace the universe's childhood, watch its adolescence in galaxies, and glimpse its slow maturity in the fading of starlight. We stand at the perfect intersection between light and time, a moment when the past is still arriving and the future is still forming. And when you think of it that way, you realize something profound. The universe's true size isn't measured in kilometers or light years. It's measured in moments of visibility, in the fragile window when awareness meets light. We are that window. Consciousness itself is the universe observing its own horizon. You are not merely watching the stars. You are the means through which the universe becomes aware that it has stars at all. You are its reflection, its witness, its quiet realization. And maybe that's why it feels so peaceful to gaze into the night, because in that stillness, you're not separate from what you see. You are part of it. The light entering your eyes tonight began its journey before you existed, and now, through you, it finally finds its meaning. The universe's edge is not a wall, it's a meeting place, where time, light, and awareness touch for just a moment. And in that moment, everything becomes infinite. When we think of the size of the universe, our minds reach outward. We picture distances, galaxies scattered across vast blackness, light travelling for billions of years. But the true scale of the cosmos isn't only in space, it's in time. Space is wide, but time is deep. If you could pour the universe into a single image, it would look less like a map and more like an ocean, each wave a different era, each ripple a different age. The cosmic sea has been unfolding for 13.8 billion years, but its story stretches far beyond that. Let's drift through it together, slowly, like explorers gliding through epochs. The first wave is called the Planck era, a time so brief it defies comprehension, 10 to the minus 43 seconds after the Big Bang. The universe then was smaller than an atom, hotter than any furnace, and ruled entirely by quantum gravity. Time itself was just beginning to take shape. Then came the grand unification era, when the fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, began to separate, each writing a different rule for how matter would behave. In the blink of a cosmic eye, the universe expanded unimaginably fast. That was the inflation era, the instant when space itself ballooned from subatomic to astronomical size. This expansion stretched tiny quantum ripples into vast cosmic structures, the seeds of every galaxy that would ever exist. Next came the quark era, when the universe was a blazing soup of fundamental particles, quarks, electrons, neutrinos, all colliding, merging, annihilating. The density was so high that no atoms could form. It was chaos, pure and beautiful. As the universe cooled, quarks joined together to form protons and neutrons, the building blocks of matter. Then came the hadron era, lasting just a few seconds. In that fleeting moment, the ingredients of all stars and planets were forged. 3 minutes later, the first light elements appeared: hydrogen, helium, and traces of lithium, born in a process called nucleosynthesis. The universe, still glowing, was about 75% hydrogen, 25% helium, the simple recipe from which everything else would grow. But light still couldn't travel freely. The universe was a dense fog, photons trapped by constant collisions with charged particles. That lasted for 380,000 years, until the recombination era, when the universe cooled enough for atoms to form. Suddenly, light was free. That light still fills space today as the cosmic microwave background, the oldest photograph of reality. After that, darkness fell. For hundreds of millions of years, the universe was invisible, filled with neutral gas and no stars. It was a cosmic night before the dawn. Then gravity gathered hydrogen into clouds, and the first stars ignited. That was the cosmic dawn, around 100 million years after the Big Bang. The first galaxies were born, small and irregular, glowing in a sky that had never seen starlight before. This era lasted billions of years. The stelliferous era, the age of stars. It's the time we live in now, a golden age of brilliance, where galaxies bloom and consciousness evolves. Our sun is one of hundreds of billions in the Milky Way, a middle-aged star in a universe still vibrant with energy. But like all golden ages, this one won't last forever. In the far future, when the last star burns out, a new age will begin. The degenerate era. For trillions of years, the universe will glow only with the heat of cooling white dwarfs and the slow rotation of neutron stars. Galaxies will fade, their brilliance dissolving into cold memory. After that comes the black hole era, when gravity itself becomes the universe's last sculptor. Stars will collapse, matter will vanish into singularities, and black holes will rule the dark. But even they will not last. Through Hawking radiation, they will slowly evaporate, some taking longer than 10 to the 64th power years to disappear. Finally, the universe will enter its quietest age, the dark era. No stars, no light, only thin, scattered particles drifting endlessly through space that has grown too vast to measure. It will not be the end, not exactly, just the cooling of a great fire. the embers of existence floating through infinite night. And yet somehow, the story remains peaceful, because the same laws that gave rise to life, to light, to consciousness, still hum beneath that silence. The universe, even in its quiet, will still be expanding, still existing, still being. The size of the universe, then, isn't just the span of space, it's the reach of time. It's not just how far it goes, but how long it remembers itself. And right now, here, tonight, you live in the most luminous chapter of that story, a brief moment when the stars still burn, when galaxies still sing, when light still travels freely through the dark. You are alive during the universe's age of brilliance, and maybe, just maybe, that's not a coincidence. When you look up at the night sky, you are not seeing the present, you are seeing the past, a living timeline of the universe's memory. Each star, each shimmer of light, carries a story from a different moment in cosmic history. The closest stars tell tales from years ago. The Andromeda Galaxy shows itself as it was 2.5 million years ago. The faintest galaxies in the Hubble Deep Field shine from over 13 billion years in the past, almost to the dawn of creation itself. The night sky is not a picture, it's a recording. Every point of light is a timestamp. Light travels at 300,000 kilometers per second, fast enough to circle the Earth 7 times in a single heartbeat. And yet, even at that speed, the universe's distances turn light into time. To see far is to look backward. When you gaze at the stars, you are not watching them as they are, but as they were. Some have already died, others are still being born. You are looking at ghosts of light, echoes that have crossed eternity to reach you. It's humbling to realize that your eyes are receiving messages older than humankind itself. Every night the past falls softly on your face. And here's the quiet miracle. The farther we look, the younger the universe becomes. Each layer of space is also a layer of time. When telescopes peer into the deep infrared, the stretched, ancient light of distant galaxies, they are not just seeing faraway places, they are witnessing cosmic history unfolding before stars like our sun even existed. The James Webb Space Telescope has captured light from galaxies formed just a few 100 million years after the Big Bang, light that has been travelling since the universe was less than 1% of its current age. That light is only now arriving. It has crossed epochs, crossed expansion, crossed silence. When we talk about how big the universe is, perhaps this is the truest answer. It is as big as the distance between when and now. Every photon you see tonight began a journey before your life, before your world, before your species. It has never stopped moving until this moment when it touches your eye and its story ends. And in that ending, you become part of it. You are the final chapter of its 13 billion year voyage. There's something poetic about that. You are not outside the universe, observing it. You are one of its organs of perception, the universe looking back on itself, through time, across distance, within consciousness. If you could see light not as brightness, but as time, the sky would look like rippling layers, recent stars near, ancient galaxies deep, and behind them all, the faint red echo of the beginning. Every photon, a bead on the thread of forever. We measure the universe in numbers, billions of years, trillions of kilometers. But what we really measure is light's patience. The universe is large because it waits. It has waited for its own light to return to itself, for stars to die and be reborn, for consciousness to open its eyes and ask, how big is all this? And perhaps the answer is hidden in the act of asking, because to ask is to notice, and to notice is to participate. You are a momentary awareness inside eternity, a brief flicker between two infinities, the past that sent the light and the future that will never end. And yet this brief flicker is enough to illuminate everything. Every second, billions of photons enter your eyes, tiny messengers from across time, and inside you, they end their long flight. They become vision. They become meaning. They become you. The universe, in that sense, has finally found a way to see itself. So the next time you look up and feel the hush of the stars, remember, you're not staring into space. you're looking into history, into the long memory of light. And that memory, like the universe itself, is endless. Let's begin close to home. Earth, our island, our cradle, our tiny blue spark in a black sea. It feels vast to us, stretching from horizon to horizon, yet in the cosmic sense, it's a grain of dust caught in sunlight. Our planet's diameter is about 12,000 kilometers. You could walk that distance in 250 days if there were a road around the equator, but in space, it's less than nothing. Light crosses that distance in just 0.04 seconds. Now imagine the moon hanging quietly in the sky, 384,000 kilometers away. That seems far, but light covers it in a little over a second. You could fit 30 Earths in the space between us and that pale companion. Next, lift your eyes toward the sun, 150 million kilometers. The distance light covers in 8 minutes. That's our astronomical unit, the first rung on the cosmic ladder. Our planet orbits that blazing sphere, a star of medium size, a middle-aged sun among billions. It feels massive, and it is. The sun is 1.4 million kilometers wide, a glowing sphere so large that more than 1 million Earths could fit inside it. Every second, it releases energy equal to 100 billion nuclear bombs. Yet even that power is ordinary in the grand hierarchy of stars. Our sun is a G-type main sequence star, a quiet, steady flame. But some stars dwarf it beyond comprehension. Consider Rigel in Orion, 70 times larger in diameter, shining nearly 100,000 times brighter. Or Antares, the red heart of Scorpius, 800 times wider than our sun. But even those are outshone by Uy Scuti, one of the largest known stars, a swollen red supergiant. If placed where the sun is, its edge would extend past Jupiter's orbit. Imagine that, a star so huge it could swallow our entire solar system in its fiery lungs. And yet compared to the space between stars, even these titans are small. The nearest star beyond the sun, Proxima Centauri, lies 4.24 light-years away. That's 40 trillion kilometers, so distant that if our fastest spacecraft left today, it would take more than 70,000 years to arrive. Space between stars is mostly empty, vast, silent, dark. If the sun were a single grain of sand, the nearest star would be another grain nearly 10 kilometers away. Between them, nothing but night. And still those grains, those isolated stars, gather. Gravity draws them into clusters, swarms, and great spirals of starlight. These are galaxies, the grand cities of the cosmos. Our galaxy, the Milky Way, stretches 100,000 light-years across, containing over 400 billion stars. It rotates slowly, one full turn every 230 million years. The last time we were in this position, in our galactic orbit, dinosaurs had only just begun to roam the Earth. The scale grows quickly now, faster than the mind can hold. If you reduce the Milky, begin with what you know, a handful of soil, a pebble, a single leaf trembling in the wind. All of it rests on a sphere of rock and ocean called Earth, a world so immense to our senses that we can walk for a lifetime and never reach its edge. Yet the universe holds no edges like ours, only horizons. And even here, at the very beginning of our climb through size, we already live on something small beyond measure. Earth is 12,000 kilometers across, vast enough to cradle oceans, mountains, and clouds, but small enough that light, traveling at 300,000 kilometers per second, can circle it 7 times in a single heartbeat. We call this planet home. It holds everything we have ever known, every language, every love, every story whispered through history. Yet to the cosmos, it is no more than a glimmer, a mote suspended in sunlight. Look upward. The moon, pale and constant, drifts 384,000 kilometers away. It is both close and unreachable, hanging in silence. Light takes just a little more than a second to cross that space. When you gaze at it, you are seeing what sunlight looked like 1 1/3 seconds ago, a reflection of light that has already left. Even here, distance begins to turn into time. Now imagine you keep going. You move beyond the moon, through a cold void threaded with dust and ancient light, toward the star that defines us. The sun is 150 million kilometers away, a furnace so vast that a million Earths could fit inside it. Its heat, its energy, its brilliance are what bind the solar system together. Without it, there would be only frozen darkness. And still, compared to the universe, it is an ember, a small steady flame among billions. Every second, the sun releases the energy of 100 billion atomic bombs. Yet to the galaxy, it is unremarkable. One soft note in an endless symphony. It is not the largest star, nor the brightest, nor the oldest. It is ordinary, and that ordinariness is what allows us to exist. But look farther and the meaning of large begins to change. There are stars that could hold the sun in their shadows. Betelgeuse, red and bloated, glows nearly 800 times wider than our sun. VY Canis Majoris, a dying supergiant, could swallow the orbit of Saturn. And then there is UY Scuti, among the largest known, so vast that if placed at the centre of our solar system, its surface would stretch beyond Jupiter's path. These are the heavy hearts of galaxies, stars so large that their deaths can shake space-time itself. When they die, they collapse into black holes, invisible cores of gravity so strong that not even light can escape. But even such titans are scattered like dust across the gulfs between suns. The nearest star, beyond our own, Proxima Centauri, lies more than 4 light years away, 40 trillion kilometers of emptiness. If the sun were a single grain of sand, Proxima Centauri would be another grain 10 kilometers distant. Between them, the dark would be absolute. Our galaxy, the Milky Way, is built from these lonely fires, hundreds of billions of them, bound together by gravity's quiet hand. From afar, it would look like a soft spiral of light, a slow whirl of silver across blackness, each arm dusted with stars. It spans 100,000 light-years from edge to edge. Light itself needs 100,000 years to cross it. If our sun were a single cell in the human body, the Milky Way would be larger than the body itself, a galaxy made of galaxies. And still, even this grandeur is only a single whisper in something larger. Because beyond the Milky Way, there are others, countless others, drifting in the night like lanterns on an infinite sea. Our nearest neighbour, the Andromeda Galaxy, shines from 2.5 million light-years away. Its light began travelling when early humans were shaping stone tools. The galaxy we see tonight is not what it is what it was, long before our ancestors had names for stars. And in another 4 billion years, the Milky Way and Andromeda will meet. They will not crash like two stones, but merge like ghosts, their stars passing through each other, their arms intertwining, their black holes spiralling together until they become one. So already, even before we step beyond our local skies, we find a scale that bends the mind. Distance is so great that years become light, and time itself becomes a unit of space. The ladder of immensity stretches upward still, from planets to stars and from stars to galaxies, from galaxies to clusters, from clusters to superclusters, each level wider, quieter, older. And somewhere, inside all of it, you, a momentary awareness standing on a small planet, listening to light that began before you existed. You are the smallest thing in this story, and yet somehow also the one that can see it. Now, lift your gaze even higher, beyond our spiral of stars, beyond the reach of Andromeda's light, and the universe begins to reveal its grand design. Galaxies do not float in isolation. They gather. They cluster together in families, bound by gravity, drawn toward one another through filaments of dark matter invisible to our eyes. Our Milky Way is part of a neighbourhood called the Local Group, about 80 galaxies bound in a slow cosmic dance. Some are grand, like Andromeda, others are small and fragile, tiny smudges of light with only a few million stars. The entire group spans 10 million light-years, But the local group is just one island in a vaster archipelago. All around us, clusters of galaxies form rivers and walls, immense patterns of structure that stretch across hundreds of millions of light years. Together, they form what we call the Virgo supercluster, a region containing thousands of galaxies, spread across 110 million light-years of space. If you could see it from afar, it would look like a swirling bloom, a galactic flower floating in the dark. And even that flower is part of something larger still, a web of superclusters bound together by the faint threads of gravity. Astronomers call our region Laniakea, a Hawaiian word meaning immense heaven. It is a supercluster of superclusters, 520 million light-years wide. The Milky Way lies in one of its filaments, like a single droplet of dew hanging from a cosmic strand. Everything we can see, every star, every galaxy, every distant beam of light is part of that immense structure. Imagine it for a moment. Hundreds of thousands of galaxies, each holding billions of stars, all flowing along invisible rivers of gravity through a dark sea. If you could step outside the universe and look back, you wouldn't see a random scattering of light. You would see a pattern. The universe would appear as a vast web, glowing filaments intersecting at bright nodes where clusters reside, surrounded by enormous voids of darkness. Those voids, some hundreds of millions of light years wide, are nearly empty. You could travel through them for eternity and never see a single star. And yet they are not nothing. They are the silent framework that gives shape to everything. It is humbling to realize that the greatest structures in existence, filaments, walls, clusters, superclusters, all arise from tiny ripples in the universe's first moments, from fluctuations smaller than atoms, amplified by gravity, stretched by time, sculpted by patience. The largest known structure we have found is called the Hercules, Corona Borealis Great Wall, a chain of galaxies over 10 billion light-years long. Light from one end would take 10 billion years to reach the other. To look across it is to look through most of cosmic history itself. But even this unimaginable expanse may be just one thread in a tapestry too vast to name. When you stand under the night sky, you are seeing only a few thousand stars, a local whisper of the galactic song. Beyond them lie billions of galaxies. Beyond those, clusters. Beyond clusters, structures so large that light cannot yet reveal them. And yet you can feel them, not in the way you feel warmth or wind, but in the deep intuition that tells you this is home. Because everything, from the grain of dust beneath your fingernail to the largest cosmic wall, is made of the same matter, bound by the same laws, born from the same single spark that ignited the beginning of time. You are not separate from the architecture of the infinite. You are a tiny piece of it, awake for a moment, reflecting on itself. And perhaps that is the truest measure of size, not how far space stretches, but how deeply it connects. In the silence between galaxies, in the hush between heartbeats, the same truth hums quietly. Everything is one, and that oneness is as vast as forever. Every light you've ever seen, every star, every galaxy, every shimmer of cosmic dust exists against something else, a darkness so deep it seems endless. We call that darkness space, but that word is too small. It is not merely emptiness, it is the quiet framework of creation, the stage upon which everything luminous performs. Between the grand filaments of galaxies, between the clusters and walls, lie voids, regions so vast that words lose their shape inside them. These are the cold deserts of the cosmos, some stretching hundreds of millions of light-years across. The Bootes Void, one of the largest, is a sphere nearly 330 million light-years wide. Inside it are only a handful of galaxies, lonely beacons adrift in a sea of absence. If our galaxy were placed at its centre, we would see almost nothing in any direction. No constellations, no glittering arch of the Milky Way, only darkness and the faint memory of light. The scale is incomprehensible. If each galaxy were a grain of sand, The Booty's void would be a hollow the size of Earth. Scientists believe these voids formed naturally as gravity pulled matter into filaments, leaving the spaces between almost empty. But standing within one, if you could, would feel less like standing in emptiness and more like standing inside time itself. No up, no down, no motion, only the slow whisper of the universe expanding. It's easy to imagine such a place as dead, but even in the deepest silence, something remains, a trace of hydrogen, a drift of neutrinos, the faintest echo of starlight still moving through the dark. And if you listen closely, if you imagine the universe not as a picture, but as a sound, you might sense it, a deep, low hum that has existed since the beginning. The cosmic microwave background, stretched by billions of years of expansion, still murmuring softly through every corner of space. That hum fills even the voids. There is no place in existence where it cannot be found. The silence between galaxies is not absence, it is potential, the universe at rest, waiting for its next note. Imagine yourself drifting through it, your craft gliding without a sound. No stars, no planets, no horizon, just the faint glow of a single photon, travelling for eons. It brushes past you like a forgotten sigh, the last trace of a galaxy long gone. Time slows there, distance stretches, even thought seems to echo. In that vast dark, the word big loses meaning. The void is so immense that the mind can no longer measure. And yet, it is not empty of significance, because the same physics that governs the shining stars also governs the space between them. The dark is not separate from the light, it defines it. Without the void, galaxies could not exist. The empty spaces create the pattern, the contrast, the rhythm. Every silence in the universe is part of its song. Perhaps that's what makes the void so haunting. They are the universe's pauses, the places where creation takes a breath. And if you could drift through them long enough, you might feel something strange, peace. Because in the end, the darkness is not hostile. It's simply vast. It holds everything, even light, without judgment, without urgency. Out there, you would understand what infinity truly means. It is not endless brightness, it is endless stillness, and yet even the great silence is not the end. Beyond the voids, beyond even the most distant clusters we can see, there is something greater still. Not darkness, but the unseen, the part of the universe that lies forever beyond our reach. That's where we go next. Every telescope, every sensor, every ray of captured light, all of them together give us only a glimpse of the universe. We call that glimpse the observable universe. It's the sphere of all we can ever see, about 93 billion light-years across. Beyond it lies the unobservable universe, stretching far past the reach of light, past the reach of time, past the reach of imagination. But before we cross that horizon, it helps to understand what it truly is. The cosmic horizon isn't a wall, it's a limit, the farthest distance from which light has had time to reach us since the universe began. Anything farther away is still there, still real, but its light hasn't yet arrived, and perhaps never will. It's like standing in a fog so deep that only nearby lanterns are visible. You know there are others out there, but their glow hasn't yet touched you. Our telescopes, Hubble, James Webb, Planck, all peer toward that fog's edge. They've seen galaxies from when the universe was barely 300 million years old, and the faint afterglow of the Big Bang itself. But there's always farther to go, always more beyond the veil. Beyond our cosmic horizon lies the invisible universe, a region we can never observe directly. It could be hundreds, thousands, even millions of times larger than the part we see. And because space is expanding faster and faster, most of that distant light will never reach us. The galaxies there are moving away faster than light itself. They are lost to eternity. That realization that we can never see most of reality should make us feel small. And yet it doesn't. It makes us aware. We exist inside a visible bubble, surrounded by infinite possibility. What lies beyond could be more galaxies, more light, more matter, or perhaps regions where the laws of physics themselves are different. The boundaries of our knowledge are not the boundaries of the universe. And if the multiverse is real, if space beyond our horizon is still inflating, then our entire universe is just one pocket among countless others, each born from its own spark of creation. Imagine for a moment that you could rise above the cosmic horizon and look back. You'd see our observable universe not as a sphere of stars, but as a tiny glowing bubble suspended in the darkness. One bubble among endless others, each expanding, each dreaming its own history. And all of them, every bubble, every void, every filament, suspended in a vast, invisible ocean of space-time, still expanding faster than any light can race. You cannot see beyond it, you cannot measure it, but you can feel it, in that quiet awe that comes when you stare into the night and sense there is more, always more, waiting just beyond what you can know. That feeling is the edge of sight, the limit of light, the moment when knowledge becomes wonder. And it's here, at this horizon, that the universe becomes something greater than science. It becomes a mirror. Because what lies beyond is unknowable, and yet it calls to us, the same way the dark ocean calls to those standing on its shore. You can't see the far side, you can only imagine it. And in that imagination, the unseen becomes alive. Perhaps that's the universe's final secret, that it was never meant to be fully known. Its mystery is not a flaw, it's the essence of its beauty. We stand on the inner surface of infinity, looking outward, knowing we will never reach the end. And yet that doesn't stop us from trying. The universe is not only bigger than we imagine, it is bigger than we can imagine. Still we look up, still we wonder, still we dream. And in that dreaming, we become part of the mystery itself. The universe we see is not the universe that is. The stars, the planets, the nebulae, all that glittering light make up less than 5% of everything that exists. The rest here is hidden, unseen, silent. Astronomers call the missing mass dark matter, though the name is more confession than description. It does not shine, does not absorb, does not reflect. It simply is, a shadow presence woven through the structure of the cosmos. We know it's there because of how it pulls. In the 1970s, astronomer Vera Rubin studied the way galaxies spin. She found something astonishing. The stars on the outer edges of galaxies weren't moving as expected. They were moving too fast. By every law of visible physics, they should have flown apart, scattermired into the dark, but they didn't. Something unseen was holding them together. That something was dark matter, an invisible halo surrounding each galaxy, outweighing its stars and gas by a factor of 5 to 1. It doesn't glow, it doesn't decay, it doesn't collide with the light we see, but it shapes everything. Without dark matter, galaxies could not have formed. It is the skeleton of the universe, the framework upon which all luminous matter gathers. The great cosmic web we see through telescopes, the vast filaments of galaxies, are merely the bright frost on the invisible branches of dark matter. Think of it like this. If all the light in the universe were snowflakes, dark matter would be the wind, unseen, but shaping where each flake falls. And even though we cannot touch it, it's all around us. Right now, trillions of dark matter particles are passing through your body, through the earth, through every atom of air. You do not feel them, but they are there, like the pulse of a deeper universe flowing through the visible one. Scientists have tried to detect dark matter directly, deep underground, in mountains, in ice. They've built detectors sensitive enough to feel a single particle of light. But dark matter remains silent. It leaves no mark. It's as if the universe is holding back one of its oldest secrets. Some believe dark matter is made of undiscovered particles, WIMPs, axions, or something stranger still. Others think it's not a substance at all, but a flaw in our understanding of gravity, a hidden curve in the way space-time bends. Whatever it is, dark matter is the unseen half of reality, the quiet weight beneath creation. And yet even it is not the whole story. Because if dark matter holds the universe together, something else is pulling it apart. Something far greater. Something we call dark energy. For most of human history, we thought the universe was steady, eternal, unchanging. Even Einstein once believed that. But then, the galaxies began to move. In 1929, Edwin Hubble discovered that galaxies are receding from us, and the farther they are, the faster they go. The universe, it seemed, was expanding. For decades, scientists assumed that gravity would eventually slow that expansion, maybe even reverse it, pulling the universe back together in a final collapse. But in the 1990s, something extraordinary was found. Two teams studying distant supernovae, dying stars that shine with predictable brightness, realized those stars were dimmer than expected. That meant they were farther away than they should be. The universe wasn't slowing down, it was accelerating. Some unseen force was pushing space itself outward, faster and faster. We call it dark energy, and it makes up nearly 70% of the cosmos. No one knows what it is. It doesn't behave like matter, doesn't clump, doesn't fade. It is not light or gravity, but something woven into the fabric of space-time itself. An invisible pressure that stretches the universe apart. You can think of it as the breath of the cosmos, a slow, steady exhalation that began with the Big Bang and never stopped. Every second, galaxies drift farther away. Every second, more space appears between them. Even now, the night sky you see is expanding, quietly, invisibly, beneath your gaze. In time, this acceleration will carry galaxies so far that their light can no longer reach us. The sky will grow darker, the stars fewer, until only our local cluster remains, a small island of light adrift in an infinite black sea. It's a melancholy thought, but there's beauty in it too, because this expansion means the universe is still alive, still in motion, still unfolding its story. No one knows what dark energy truly is. It may be the energy of the vacuum itself, a property of space, where even nothingness has a faint hum of existence. Or perhaps it's a field that changes slowly over time, something dynamic and alive. Whatever it is, it decides the universe's fate. If dark energy remains constant, space will continue to stretch forever. If it grows stronger, the universe may one day rip itself apart. Galaxies, stars, atoms, even space-time itself, torn asunder in a final event scientists call the Big Rip. And if it weakens, perhaps gravity will take hold again, and the cosmos will fall back inward. A big crunch, collapsing into fire, perhaps to begin again. For now, it simply breathes. Each second, a little more space. Each moment, a little more distance. And through it all, you are part of that expansion. Every atom in your body is carried along in that cosmic exhalation. You are growing farther from every other atom in the universe, infinitesimally, silently, as space itself stretches between them. The stars are moving, the galaxies are drifting, the cosmos is breathing. And you, sitting quietly beneath this sky, are breathing with it. In that rhythm lies something sacred. The same force that drives galaxies apart also gives rise to life, to time, to change. It is both destruction and creation, both leaving and returning. The universe, it seems, is not static at all. It is a pulse, an infinite heartbeat, and we, flickers of awareness within it, are listening to that heartbeat across the ages, feeling the breath of the cosmos move through us, through everything, through the space between every star. The unseen forces that rule the universe are not distant, they are within you. They are you, and through that quiet realization, the dark is no longer empty. It is full of motion, full of energy, full of the infinite whisper that says everything expands, everything connects, everything continues. The night sky as you know it will not last forever. Every glittering point, every soft thread of light stretched across the black, all of it is temporary. The stars are not eternal. They are burning stories, each one written in flame, each destined to fade. Imagine the far future, not 1,000 years, not 1,000,000, but trillions. The universe has grown vast and cold. Galaxies have drifted apart, drawn away by the breath of expansion. One by one, their lights have gone out. The great spirals we see tonight are ghosts now, their stars long dead, their nebulae gone, their arms dissolved into the dark. Only the faint glow of ancient embers remains, the quiet shimmer of white dwarfs cooling slowly through eternity. Even those in time will dim. 1,000,000,000,000 years from now, the last visible stars will flicker out, leaving only the hushed pulse of dying light. The cosmos will no longer shine. It will only remember. Yet this fading is not destruction. It is rest, a slow settling of the infinite into its own stillness. Imagine a night so deep that even memory grows soft. No sunrise, no moonrise, only the cold drift of time itself, quiet as snowfall. The remaining heat of the stars, spread thin across infinity, glows faintly like embers under ash. Planets still circle in darkness. Their shadows still fall upon unseen surfaces. There is no observer, no sky, no gaze, and yet the universe continues to exist. Black holes linger in the silence, their gravity eternal, their hunger infinite. They drift through the dark, swallowing what little remains. Stars, dust, light, even the radiation of emptiness itself. But even they cannot last forever. In time they too will fade, their strength unravelling in whispers of heat and energy. One by one, they will dissolve into the background, a soft sigh of evaporation. And then, the universe will know a new kind of quiet, a quiet beyond sound, beyond time. This is the great silence, not an ending, but a stillness so complete that it becomes a kind of peace. Every spark of light that ever lived has returned to shadow. Every wave of energy has stretched too thin to be seen. Matter itself will decay into smaller and smaller forms until there is only the faintest dust of existence, the cosmic afterglow of everything that ever was. In that silence, you might imagine that the universe dreams. Dreams of its own beginning, when it was hot and young and full of light. Dreams of galaxies blooming like flowers. Dreams of life, of eyes that once looked up in wonder. All those dreams remain within it, not lost, just quiet, because even as the last lights fade, the memory of brightness lingers in the weave of space-time. The universe does not forget. It carries every photon, every heartbeat, every whisper that ever moved within it. All the stories of creation are written into its bones, stories that will outlast every dawn. And when at last the final star exhales its final breath of light, there will still be warmth somewhere. A trace of what was, a small eternal glow, fading into infinity like a candle in the wind, and the darkness that follows will not be empty, it will be full of the quiet hum of completion. For the universe, having sung its long and luminous song, will finally rest. And after the long silence, after the last whisper of light has vanished, there comes a stillness so deep that even time forgets how to move. In that endless hush, the universe becomes something different. It is no longer expanding or collapsing, it simply is. There are no stars now, no galaxies, no heat, no cold, only equilibrium. The perfect balance between all that was and all that will ever be. And within that balance lies something sacred, a symmetry too complete for words. You might think of it as death, but it isn't. It's more like sleep, the universe folded into itself, resting, gathering, dreaming. Perhaps within that dream, the seeds of new creation begin to stir. For energy never truly dies, it only changes form. Somewhere in that endless dark, quantum ripples still tremble, tiny fluctuations of nothingness that remember what it means to be. One may swell, another may bloom, and from that bloom, space may unfold again. Another dawn, another breath, another universe. This is not certainty, it is possibility. The soft promise that endings are never absolute, because even in silence, potential remains. The cosmos may rise again, born not from fire this time, but from stillness. And the cycle may begin anew, time reborn from timelessness, light from shadow, expansion from rest. Perhaps this has happened before, perhaps it will happen again, Perhaps the universe has no beginning and no end, but only an endless rhythm of becoming, the eternal inhale and exhale of creation itself. To think of this is not to shrink before infinity, but to be comforted by it, because it means nothing is ever truly lost. Every star that burned, every being that dreamed, every thought that flickered through consciousness, all of it becomes part of the fabric again, returned, rewoven, remembered. And maybe that's what eternity truly is. Not endless duration, but endless renewal. When everything becomes one again, there is no loneliness, no separation between the observer and the observed, between the starlight and the one who watches it. Everything folds into everything. All boundaries dissolve. You are not apart from that. You are part of the great return. The atoms that once burned in suns now breathe within you. The light that once crossed galaxies now shines through your thoughts. And one day those same atoms, that same light, will drift outward again, to become something else, a new world, a new sky, a new dream. So when you think of endings, think of them softly. Think of them as moments of rest in an infinite song. For the universe has always been singing, through stars, through galaxies, through you. And though one verse may close, another will begin. Maybe not in your lifetime, maybe not even in your universe, but somewhere, somehow, the rhythm continues. And in that rhythm, everything finds its way home. The cosmos, once vast and loud, now hums in perfect quiet, a lullaby for itself. It does not vanish, it transforms, it does not end, it begins again, forever. The universe is not only outside you, it lives within you. Every atom in your body was born in the heart of a star. Every breath you take contains traces of the first light. You are not merely standing beneath the universe. You are a small part of it, remembering it itself. Look at your hands for a moment. The calcium in your bones once burned inside a sun. The iron in your blood was forged in a supernova. The carbon in your skin was gathered from dust that drifted through ancient space before Earth was even born. When you touch the world, the universe touches itself through you. That is how deeply you belong. We often speak of distance, of light years and galaxies, of what lies far beyond our reach. But perhaps the greatest vastness is not out there at all. It is inside thought, inside awareness. Close your eyes, feel how the mind unfolds without edges, how memory stretches in every direction, how imagination builds stars and worlds from silence. You contain an inner sky as endless as the outer one. When you wonder about the stars, it is not curiosity reaching upward. It is recognition. Some quiet part of the universe, arranged in the shape of a human, remembering where it came from. That is why wonder feels like coming home, because in the stillness behind every question, there is something ancient listening back, a reflection of yourself spread across the cosmos. The photons that began their journey billions of years ago now end it in your eyes. You are the final surface upon which they rest, the place where their story becomes meaning. Light does not travel only through space, it travels through consciousness. It begins in stars and ends in awareness, and in that way, you are the completion of the universe's oldest journey. Perhaps that is why the night sky feels both infinite and intimate. It is not something you look at, it is something you awaken in. Every breath, every thought, every heartbeat is made of the same energy that moves galaxies. The rhythm that turns stars in their courses is the same rhythm that stirs in your chest. You are not a visitor here. You are the universe, in brief, in bloom, in wonder. So when you feel small beneath the sky, remember, small things can hold infinity. A grain of sand, a drop of water, a single heartbeat, all are vast enough for the entire cosmos to echo through. The stars above you and the atoms within you follow the same law, speak the same language, move to the same music. And that music, a quiet, patient, eternal, is still playing. You are one of its notes, a momentary chord in an endless song. When you close your eyes tonight, you do not leave the universe behind. You drift deeper into it, into the inner expanse where silence and thought meet. and where infinity becomes personal. Out there, the galaxies spin. In here, awareness turns gently through its own constellations of memory and dream. They are not separate, they never were. If you could stand outside the Milky Way and look back, the Earth would be invisible, smaller than dust, lost in the light of hundreds of billions of suns. And yet within that invisible speck, minds have risen that can imagine the whole. That is the quiet miracle. From the perspective of size, we are nothing. From the perspective of awareness, we are everything. Because the universe, for all its magnitude, has only recently learned how to see itself. For billions of years, there were only stars and stone and gravity. No eyes, no thought, no wonder, only motion. Then, on one small world, matter began to dream. Through the slow turning of time, through ocean and dust and breath, the universe formed a way to look back upon itself. It became conscious, and so it came to be that starlight could look at starlight and know what it was seeing. You are that knowing, a point of awareness through which the cosmos perceives its own vastness. That is what makes you sacred. Not your power, not your permanence, but your capacity for wonder. Every time you look up at the night sky, you complete the universe's most ancient equation: observer and observed, infinite and intimate, light and mind. When you look up, the universe looks back. It is not a gaze of judgment, it is recognition, the reflection of itself in fragile form. And in that reflection, something beautiful happens. Infinity becomes tender. The unimaginable becomes close enough to feel. We call it awe, but perhaps awe is just another word for belonging. The galaxies are not far away. They are woven into your breath. The dark between stars is the same stillness that fills your chest when you fall silent. You carry the map of creation, not in your hands, but in your being. You are made of its dust, sustained by its light, destined to return to its silence. That is not tragedy, that is symmetry. Everything that begins must rest, everything that shines must dim, but the essence, the pattern, remains. You are a brief flame, yes, but you burn with the memory of suns. So when you walk beneath the stars, walk gently. Each step you take is upon the skin of the universe itself. Every heartbeat sends a ripple through the same fabric that holds galaxies in their spin. And perhaps one day, long after the last light has faded, that ripple, the echo of your existence, will still move quietly through the dark. The universe will remember you, not as an individual name or face, but as part of its eternal music. A note that was played once, softly, perfectly, and never forgotten. So rest easy tonight beneath the endless sky. You are part of its story. You always were. The universe is vast, but so are you. And together you are one silence, one song, one small light that never truly goes out. And now, after the long journey outward, past the stars, the galaxies, the horizons, and the silence, you begin to drift home. Not to a place, but to a feeling. To the quiet truth that you are never far away from anything at all. The universe is not something you travel through. It is something that unfolds within and around you at once. Every breath, every pulse of thought, every heartbeat has been part of its rhythm since the beginning. When you look out into the stars, you're not seeing something separate from yourself. You're seeing your own origins scattered in space. You are a continuation, not an observer. You were there in the atoms that formed the first light. You were there in the dust that gathered to make the sun. You were there in the carbon that became life, and in the silence that gave that life a moment to wonder. And here you are again, full circle, looking back at the sky that made you. The journey outward was never about distance, it was about remembrance. Every fact, every number, every glowing star you passed along the way, all of it was a mirror, showing you what you already are, an expression of the same vastness you've been trying to measure. You cannot fall out of the universe. You cannot be lost from it. No matter where you go, you remain within it, as inseparable as a wave from the ocean, as eternal as the space between breaths. Let that thought settle in you now. like starlight fading into dusk. The great galaxies are still spinning. The cosmic web still hums its endless, invisible song. But within all that motion, there is also this stillness. You, lying quietly, the sound of your breathing, steady as orbit, the warmth in your chest, slow as a sunrise. This is the same stillness that lives between the stars. It is the universe's own resting state, mirrored within you. So when you feel small, remember, you are not small. You are precise. You exist exactly at the scale where awareness becomes possible. You are the bridge between the infinite and the intimate. The universe needed something small enough to feel it, to see it, to speak its story aloud. And that something became you. You are not at the edge of creation. You are its center, as is every being who looks up and feels the same quiet wonder. Because in a universe without boundaries, every point is the center. Every consciousness is a light. Every breath is a star being born again. The cosmos does not end in distance. It ends in awareness. And that awareness, gentle, human, fleeting, is enough to make infinity complete. So rest in that thought and let it settle over you like stardust. You have seen the scale of everything, and you have found yourself within it. You are home. Now the journey softens. The stars grow dim at the edges of thought. The words slow, like a tide ebbing into silence. You are lying beneath the same sky that has existed for billions of years, a sky that has watched galaxies form, worlds turn, and time itself unfold like a dream. The air around you hums with ancient photons, the faint glow of the beginning still echoing everywhere. That light touches your skin, passes through you, joins the warmth of your breath. The universe is still moving, expanding, changing, breathing, and you are part of that breath. Each inhale is the gathering of starlight. Each exhale is the release of galaxies. And somewhere in that rhythm, between the rise and fall of your chest, the infinite and the intimate meet. You have travelled so far, through ages and distances, through silence and fire, through creation and return. And now, there is only calm. The stars above are still burning, but their light feels softer now, like a lullaby whispered across eternity. The darkness between them is no longer cold. It is gentle, like velvet, like sleep. You are safe here. You always have been. The same laws that hold the galaxies together hold you too. Gravity, time, space, all woven around you in perfect balance. You are carried by the same hands that cradle entire worlds. Nothing in the universe is separate from you. Not the light, not the dark, not even the silence. Everything moves together, one vast slow heartbeat. And as you listen to that heartbeat, the steady hum of existence, you begin to drift. Your thoughts become lighter, your awareness becomes wider. You begin to dissolve gently into the same stillness that fills the night sky. The stars fade into memory, and you follow them, not away, but inward into the calm center of everything. You are no longer measuring the size of the universe, you are becoming it. Each breath stretches across galaxies, each moment folds softly into eternity. You are the echo of creation, returning to silence. And as your eyes close, the universe closes with you, not ending, but resting. The galaxies continue to spin, the light continues to travel, but here, in this moment, everything is still. The cosmos exhales, and you exhale with it. The cosmos rests, and you rest with it. Sleep now, inside infinity. You are starlight returned to peace. You are the universe, dreaming itself quiet once more. The night has deepened. The stars, once countless, have become fewer now, soft, blurred memories above the edge of thought. You can feel the weight of stillness settling around you, like a slow snowfall of silence. All the distances you crossed, the galaxies, the superclusters, the endless dark, now feel near. The entire universe has folded inward until it rests inside the small circle of your breath. There is no need to measure anymore, no need to name or know. Everything that was vast has become simple. Everything that was far has come home. If you listen closely, you can almost hear it, the hush of light reaching its end, the faint sigh of space continuing its gentle expansion, the patient rhythm of a cosmos too large for hurry. Each star that shines tonight is older than memory, yet each beam of light finds its way here, to you. That is what the universe has been doing all along, travelling just to arrive in this moment of awareness. And now it rests. The galaxies spin but slowly. Time moves but softly. Even gravity seems to breathe in longer, quieter intervals. This is the horizon of quiet, not an edge but a moment of perfect balance between being and becoming. You are weightless here, suspended between what was and what will be. The universe holds you as gently as it holds its stars. You can let go of everything now. All the facts, the figures, the endless distances, they were only maps leading you back to stillness. The real measure of the universe was never in kilometers or years. It was in the space between heartbeats, in the silence that allows light to exist at all. Close your eyes and see without sight. The darkness behind your eyelids is the same as the dark between galaxies, rich, full, alive. Inside it, every possibility rests, waiting. You are not falling asleep beneath the universe, you are falling asleep within it. Your breath rises and falls with the same rhythm as nebulae forming and fading. Your pulse mirrors the slow heartbeat of time itself. Nothing separates you from the stars now. You have returned to the same stillness they were born from. Let the thought fade, let everything fade. There is only peace, quiet, and the soft shimmer of being. The universe watches itself sleep, and through you, it dreams. The journey is complete. You began in light, travelled through immensity, and arrived in calm. You have seen the universe in its vastness, its stars and shadows, its birth and its resting, and you have found that all of it lives within a single, steady breath. Now the words grow slow, softer than sound, each one a final ripple across the surface of awareness, fading gently into stillness. Outside, the stars keep shining. They do not hurry, they do not fear. They simply are, constant, serene, eternal. And inside, the same quiet spark glows in you. It is not smaller than the stars. It is made of the same fire. It has been burning since the beginning, through countless forms, through every age of the cosmos. You are the universe's whisper, the soft echo of its first light. When you rest, it rests. When you breathe, it breathes. So now, as your thoughts grow slow and gentle, let the universe drift with you, its infinite spaces folding softly into the hush of sleep. No edges, no endings, only the deep hum of existence, steady and calm. The galaxies turn, the light travels, the silence deepens, everything continues, and in that continuation lies peace, and you are safe, you are home, you are part of everything that ever was, and everything that ever will be. The stars will wait for you. They have always been waiting. So close your eyes. Let the night take you. Let the starlight settle upon your skin like dust from creation. Sleep now, beneath the great quiet sky, within the endless arms of the universe, carried by its rhythm, held by its light. Good night, traveller of infinities. Good night, small flame of awareness. Good night, universe, until the next dawn of thought, when you awaken again and the story begins once more.